All right, welcome back, SL1 people. You guys, we've made it through chapter 2, so we're going to do an activity called closure notes, where this is literally a large list of things that could come up on an assessment. I'm not saying every single one of these things will come up on the assessment, but they could. So, you guys, chapter 2 started out talking about general functions. The first thing you should know is the difference between a relation and a function. Remember, every function is a relation, but not every relation is a function. Just like all poodles are dogs, but not all dogs are poodles. So I would know the definition of a function, which is that it has to pass a vertical line test. Each input has to map to exactly one output, but not the reverse, that you can have inputs that go to, or multiple inputs that go to the same output. That's fine, but one input can't go to multiple outputs. The way we looked at different general functions is we looked at tables, we looked at maybe just coordinate pairs, and we looked at mappings. Mappings was probably the most uncomfortable one that you guys hadn't seen in a while. Remember, it's this sort of thing where you have inputs being mapped to different outputs and things. What I'm drawing would not be a function because one input goes to multiple outputs. And we did some graphs. Now, some of the graphs we did by actually like graphing some like y equals mx plus b and stuff, but other ones we just relied on a TI graphing calculator. So I would be ready for both of those things. We might ask you to graph something and then talk about its domain or range. Oh, I'm spoiling. It's coming later. Okay, function notation. You will see the classic f of x, but be ready for the IB notation of f colon with the arrow. F of x maps to whatever. It's very similar to this one. It's slightly different. Functions are all about inputs and outputs. Be ready to put inputs into functions and find an output, or vice versa. We might give you an output and ask you to find an input. Next up, we have drawing graphs. Like I said, we did do a tiny bit of some basic y equals mx plus b, where we talked about things like slope, y-intercept. We also did a little bit of x-intercept work as well in that section. But then anything past a y equals mx plus b, we basically just used a graphing calculator to graph it up and see what it looks like. So at this point, if I throw something like this at you, y equals negative 1/2 square root of x to the third plus 2 or something like that, I don't expect you guys to know what that looks like. I don't even really know what that looks like just looking at that one. So I would reach for a graphing calculator. Be able to adjust your windows and things and make it look nice. Big topic that people always struggle with in this unit is domain and range. That's not a highlighter. Domain and range. Remember, domain is all about your inputs and range is all about your outputs. When it comes to the domain and range, we talked about inequalities. Remember, that's the alligators. For instance, like x is less than or equal to 3 or something like that. But then we did two different versions of interval notation. The IB version of x is less than or equal to 3 would be negative infinity up to 3 and including it. But then the US version would look like this. Yeah, so be ready to recognize both of these. Like if I throw something like that at you, that you can understand what it means. From graphs. Oh, we definitely did domain and range from graphs, where you have to look at like what kind of inputs are on the graph and what kind of outputs are on the graph. We definitely did a lot of continuous graphs where it's one nice curve, but then we did some graphs that were piecewise. Be ready to look at a piecewise graph, something like this, and talk about what the domain and range would be. I'm just making it up. Composite functions, the dream within a dream. Know what this notation means, fog of x. Remember that this is f of g of x. So we can ask you about fog of x, goff of x, or we could even do like, triple composite functions. So something like f of g of h of x. Maybe find something like that. Know that that's h of x inside of g of x inside of f of x. Ooh, very weird topic is domain and range of a composite function. I feel like this was touched on lightly, but it's definitely a complicated concept. You really have to understand what domains go into the inside function to cut, and sometimes the inside function will be restricted and you can't get certain numbers out of it. I would definitely go back to that section and read that example because it's a little bit tricky. Know how to do composite functions with tables and coordinates. That also came up in the notes. Like if I just give you coordinates of f and coordinates of g and ask you to find some sort of composition, you know how to feed the inputs and outputs into each other to get the right answer. The last topic was inverse functions. Know how to prove two functions are inverses of each other algebraically. Remember, that means fog of x is equal to x, but not only that, but also goff of x is equal to x. Also know the graphical relationship of inverses, which is that they are reflected on that line y is equal to x. So if I draw this right here, it's a reflection. Geez, that is not an arrow. It's a reflection around this line, y equals x. So for instance, if you have a point over here, that it would be reflected over the line at a 90-degree angle and back over here, somewhere on this side. Finding inverses algebraically. Remember, that's all about the the x and y switcheroo. So swap x and y, and then get y by itself to find an inverse algebraically. Then the very last topic was some functions are actually inverses of themselves. They're very interesting functions. So know how to prove that something might be a self-inverse, or show that something is a self-inverse by like finding its inverse. But yeah, self-inverses, that was the last topic. You guys, I think that's it. I think that's everything that could come up on a test. Look at it, all super small. All right, if you guys have any other questions, please email us.